about tech and connecting. So if you are not already on the LinkedIn or WhatsApp group, this is your chance to join it. That's where we release the latest updates, specifically WhatsApp as well. So do join, we're constantly open to feedback, open to any ideas. If you like, Samir actually reached out himself and he was like interested to do a talk, and now he's here. So if anyone has any ideas, anything you want to talk about, use this platform. All right. So job shout outs. There's a bunch of places that are hiring right now. I would start with us. Actually, at Microsoft, we are hiring right now. We have like these 3 positions open. A solution engineer, this was just announced. So you can go to our careers website to learn more about it. So if you're someone who's technical on the apps, data, or infra side, we're looking for people with a bit more experience, because even if you're new, like, do apply, don't shy away. But before you apply, just let us know, we could give you some advice and so on. So that's something I want to shout out. We have also a bunch of other places that we shared in our WhatsApp channel. I think UBS is hiring, AppLab, which is our data and AI, one of our lead data and AI partners here at Qatar, is also hiring. So just go over to their websites and then you will find that. There's also Commercial Bank. They're looking for a data engineer. Qatar Energy is also looking for a data engineer. So I'm just mentioning these things just for you to actually go there and apply. And if you're interested, you can just talk to us. And also, I'd just like to give this platform to anyone that wants to like shout out if your place is hiring, or if you're someone that is actually looking, use this opportunity, shameless promotion. Don't be shy if you want to. I'm just going to give you 5 seconds, but not going to put you on the spot. Anyone brave enough to just say anything? Okay, it's fine. I guess people are shy at the beginning, but later. Okay, yalla. So today we're going to talk about 2 things. I'm going to talk about Microsoft Build at the end of the session. So Microsoft Build is our annual developer conference where we announce all of our new technologies. So in case you haven't, it happened during like a couple of weeks ago, actually last month. Gosh, time flies. There's been a bunch of exciting announcements in the whole Microsoft ecosystem, but I'm going to focus on the AI announcements. There's a lot to cover. So if you haven't been able to attend the sessions, by the way, they're all online, free, available. You can go and check them out. Lots of great stuff by our product team. But I'm going to give you a quick recap just for you to know, what you missed, and you can dig deeper later. But before that, we have today Samir. Samir is a PhD candidate at A&M, at Texas A&M. And his research is all about building trustable LLMs, how to mitigate hallucination. He's been doing a lot of, what year of your PhD is it right now?
I just finished my second.
Yeah. How long are PhDs? 5? 4?
4.
Oh, so 2 more years. Yeah. Great. So he's going to talk all about this topic. If you don't know what hallucinations are, what LLMs are, don't worry, he's going to ease you into it. And then he's going to talk specifically about the techniques that his research group has been doing to mitigate this. And also, please listen attentively, because like Niam mentioned, we always ask questions at the end and you get to win. What do you get to win?
Coffee mug, yeah.
Your mug, yeah. Not the ones who won last time, huh?
Yeah.
Like some people are collecting. You already have, yeah.
At the end of this session, I'll have it.
Do you have for the whole? Yeah. Yes. So I'll turn it over to Samir. You can go ahead and share your screen, and then while he's doing that, do we have any questions? I'm sorry, I'm covering you guys. Yeah. Do we have any questions or anything you guys want to say? We'll get a chance to chat more outside. Okay. Yeah. Listen.
The things is setting up. I see that there are 5 people who have joined the community. I'll just approve them based on just if you are working on Qatar, that's what the main thing is. But I think we were delayed.
Yeah, so, unless some people maybe just moved to the country, then you can just let us know, because we try to, and some scammers try to join the group, so we try to avoid that.
People from Africa as well, so I'll not accept them until.
Or maybe they just moved in here from Africa. Unless if you did, just let us know.
Okay. Because their location say Africa, that's why.
Okay.
I'm just looking at the location.
Okay.
That's all I
okay. Cool. All right, Samir, you ready?
Yes.
Yalla.
Okay, so hi everyone. So as Fatma said, I'm going to be talking about hallucination LLMs today. So before I start, I'll just give a brief overview about me. So I'm, like Fatma said, a PhD candidate at Texas A&M. So my work is kind of related to trustworthy AI and AI safety. So this includes research, particularly in NLP, natural language processing, and artificial intelligence. So far, I've been sort of focused on detecting and mitigating hallucinations and also reasoning in LLMs. So things like building agentic AI or multi-agent systems for reasoning. In terms of my academic background, before the PhD, I got a bachelor's degree in information systems from Carnegie Mellon University. And within this also, I built a strong foundation in NLP and AI research through different things like coursework and also other research as well. So before I get into what we'll be working on, what I've done in my research, I think it's important that we're all on the same page about hallucinations in general, how they are created and what they look like. So we'll just give a crash course of this, and then I'll go into the stuff that we've been working on. So to kind of give you a very, very quick overview, this whole kind of craze of LLM started with transformers. So transformers was in the literature introduced in 2017. So these generative models are used for understanding and generating different types of data. So you have text, you have images, and you also have things like time series, audio, and so on. These transformers work by analyzing chunks of data that are called tokens. And the way that they work is they basically learn to predict the next token in a sequence based on previous and, if available, following tokens. So it kind of works by looking at, what's the most likely word to come after a certain word based on the data that it was trained on. So this follows a sort of autoregressive concept, which means that the output of the model, so something like predicting a word in a sentence, is influenced by the previous words it has generated. So because of this, I'll give you like a very quick overview of this. Is you see this huge evolutionary tree of LLMs, and this is just until 2023. As you know, in the past 2 years since 2023, we've had a lot of other LLMs. But generally speaking, you start in around 2018 with the more basic ones like word2vec and Glove and so on. And then, as you can see, different big tech companies, of course, including Microsoft, have contributed to this and have released different LLMs over time. Now, I think it's important, obviously, to highlight the kind of most popular one, or the one that I think kind of started this whole shift, which was ChatGPT. And the reason why I want to do this, because as you can see in the figure here, the adoption, the amount of time that it took 1 million users to subscribe to ChatGPT was 5 days. And when you compare it to some of the biggest social media platforms that we use every day, that's much faster, right? And there's many reasons for this. The main one being the very user-friendly interface, right? You don't need to have any background in AI or how to use APIs or anything like that. You're able to use it and integrate it in your day-to-day life, like a chatbot, right? So because of this kind of started this whole thing with LLMs. Everyone's interested. Everyone wants to know how they work, how to, fix certain issues that they might come up with, and so on. And again, this kind of follows into that. So using them, as we all know, I'm sure that there's many articles and a lot of research on this. It provides LLMs like ChatGPT. They give extra productivity for different tasks that we do on a day-to-day basis, like writing, grammar checking, paraphrasing, and many other tasks that used to take us some time. Now they can be automated and we can focus on the more difficult or advanced tasks, right? With anything, there's always kind of a downside, right? So one of the things that have been seen to be a big kind of, I would say, setback in LLMs that the literature is trying to solve is this issue of hallucinations. So what are hallucinations? Hallucinations, they basically refer to the generation of text that is erroneous, nonsensical, or detached from reality. So in other words, just non-factual. It's not true, right? And when you have text that's generated that's not true, this can undermine the overall trustworthiness of this AI-generated content. And as you can see, that this translated into the normal user's kind of attitude towards LLMs, because there was a survey that was conducted that found that 61% of the respondents are concerned about the spread of inaccurate or non-factual information due to AI. And one of the things that contribute to that is hallucinations in LLMs. So these concerns, they basically emphasize this urgent need to address hallucinations for two reasons. The first one is so we can responsibly use generative AI and LLMs in our day-to-day work, and also ensure the accuracy, safety, and public trust in whatever is generated by these models. So this is an image just to kind of show you quickly what an LLM might look like. A very simple user input like, can you recommend a delicious recipe for dinner? At first glance, the LLM's response seems, it seems fluent, it seems relevant. But when you kind of go into it and actually analyze it, you see that there's lots of issues with it, right? So the first thing is, first of all, it mentions lunch rather than dinner, which is not what the user wants. And second of all, it makes up facts that are not true. So things like tomatoes are rich in calcium, that's just not factually true. So that's one of the ways that it can just generate these hallucinations, and it seems like it's reliable, but it's not. So in the literature, there's different literature kind of defines hallucinations in different ways, but generally speaking, there are four types that the hallucinations can fall under. So the first one is contradictory statements. So there are three subtypes within this contradictory statement. So the first one is entity-based error. So these are basically just incorrect entities in statements that, if corrected, make the sentence factually accurate. So for example, as you know, I study at Texas A&M. If a sentence was like Samir studies at Cornell, that entity is false, right? So that's basically an entity error. And then you have a relation error, which is an incorrect semantic relationship within the statement. So something like someone X works with Y rather than X works against Y. So this relationship between the two entities in the statement. And then finally, the most general one is the sentence errors, which are these just entire statements that completely contradict evidence that we have, that's the ground truth. So something like, I was the first man to walk on the moon, that's not true. So that would be a sentence error. And the second type is an invented statement. These are statements that include entirely fabricated entities, right? So something like, Narnia is the capital of Qatar. That's just completely invented. And then the third type is subjective statements. These are expressions that lack universal validity. They're usually influenced by beliefs or opinions. So it could be true for someone, it could be not true for someone else. It's completely based on opinion. The fourth one is sort of similar to the third one, but the difference with unverifiable statements is that these are facts that we cannot directly support or contradict. So we simply don't have enough information to determine whether it's factual or not. So it could be, we just don't know yet. So also, it's important to quickly give a very high-level overview of what can cause hallucinations in these LLMs. I kind of included three main categories. There's lots of more detailed information in the literature. There's a whole body of literature on this. But generally speaking, they tend to fall under these three types. So the first one is, of course, training data limitations. So an LLM can only be as good, or any model can only be as good as the training data that you provided in the pre-training. And this is no different from LLMs, right? If it's never seen something, it could get it wrong. The second one is also somewhat related to training data, but in this case, when we talk about overgeneralization, we are considering things like if it has certain data that it's seen in its training, it can make certain patterns from this data and then apply to other unseen data. And this can sometimes cause, accuracy issues because sometimes that pattern does not apply to the certain unseen data. So that's basically what overgeneralization is. And then finally, sensitivity and misinterpretation is related to kind of the way you basically, prompt an LLM, right? So you could word something in a way that could confuse the LLM and could cause it to hallucinate because it just simply doesn't get what you're trying to tell it, right? So wording, that's why prompt engineering is a very big part of the literature as well. So as a result of all of this, since we know that there's this big limitation in LLMs, which is that they generate hallucinations, there's a whole body of literature on figuring out how to detect hallucinations effectively, so we know when it's factual or not. These existing methods in the literature tend to fall under kind of two different main categories. The first one is non-automated methods, and these include things like manual review, which just obviously having a person or a group of people manually review content to see if it's true or not. And the main obvious limitation with this is that it takes a lot of time, and these are people that you probably have to pay. So that's also something to consider. And the second one is prompt-based methods. These are basically methodologies that use the LLM itself and ask it whether what it generated is a hallucination or not. There is some positives to this, in that you just kind of keep everything contained within the LLM. But again, the obvious limitation is the bias, right? The LLM got it wrong in the first place. So what's the likelihood that it's going to be like, oh yeah, actually that's wrong? It could not give you the right answer, essentially. And the last one is cross-verification. So cross-verification is having access to a knowledge base, an external knowledge base, or ground truth data. You're able to verify whether the LLM output is same to the ground truth or not the same. And based on that, you determine whether it's factual or not. So we move on to the other type, which is the automated approaches. There are two kind of subtypes under that. So the first one is embedding-based approaches, and this kind of builds on the whole idea of cross-verification, but rather than doing it manually, you do it through embeddings. So you have the LLM output, you get an embedding representation of that. You have the ground truth or the external knowledge base, you get an embedding representation of that, and you compare them. And if there is a high similarity or if there's a low similarity, then you assume that there's a difference, and there's obviously some inconsistency. So the LLM output is most likely not true. And then the other type, which is what a lot of the literature actually looks into, is entropy-based approaches. So entropy, quickly, is basically an inconsistency measure, right? So when we talk about entropy-based approaches, we mean like if there's certain inconsistency in the LLM outputs, that probably means that the LLM is not sure of its answer, which could ultimately mean that there's probably a hallucination involved there in the output. So to kind of take these entropy-based approaches, we wanted to build on the literature when it comes to entropy-based approaches. So we came up with Syndex. So this is 3 very quick points about what it is. Obviously, I'll go into it now. So Syndex is a black box method. So by black box, we mean that it does not require any internal access to an LLM. As we know, all models can either be open source or closed source, same thing with LLMs. And so this method does not require any internal access. As long as you get an output from an LLM, that's all we need. And this is good because you can kind of use it with any LLM that you're using, regardless of whether it's open box or not. And the second point is that it uses semantic similarity to detect hallucinations. And I'll explain what that is. And finally, we quantify hallucinations based on a novel metric, which we propose called Syndex, which is Semantic Inconsistency Index. This is basically a figure of the steps. Again, specifically parts 2 and 3, I'll go through in the next couple of slides. But just to give you an overview, the first part involves, if you have a query, you have an LLM, you give that query to the LLM X number of times. So in this case, 5, as the figure is showing. And you basically get 5 different generations to the same query. And once you have those generations, you take the generated answers and you move on to the second part, which is the semantic clustering part. So this involves generating sentence embedding representation for each of the generations. And then you cluster those embeddings based on a similarity using hierarchical agglomerative clustering, which again, I'll go over in the next slide. And then finally, once you have these clusters, you calculate Syndex to basically determine how, the level of semantic inconsistency in these responses. And the intuition is obviously the higher Syndex is, the more likely that there is hallucination. So to go into part 2, I want to make sure that everyone understands the difference between normal embeddings and these sentence embeddings. So normal embeddings usually represent individual words. They go on the word level. So something like, you have the word Paris, you get a vector representation for that. And this tends to focus on local context, which can be a negative, because if you think about it, if you have 2 phrases, one that says I love Paris, one that says I hate Paris, Paris has 2 different kind of sentiments attached to it, right? But when you talk about word level embeddings, Paris will have the same vector representation in both of these phrases. So we're not able to understand what the context of the word is. That's why sentence embeddings were proposed. And what they basically do is they represent these whole sentences or paragraphs in one embedding representation. So now you have like a whole phrase, like Paris is the capital of France. you're able to get a vector representation of that because it goes through the whole sentence, all the words within the sentence. And in doing that, we capture the whole semantic meaning of the full text rather than just looking at local context on a word level. And this is very important when we think about, LLM outputs, because what we care about is whether the LLM is telling the truth or not, regardless of how it words it. That's basically the main focus here, or the main intuition behind this. So the next step, once you have all these embeddings generated, is the hierarchical agglomerative clustering. So again, a quick overview if you're not familiar. Agglomerative clustering works by, you basically start with all the individual components being in their own cluster. So in this case, you would have 6 separate clusters to start with. And then as you go up in the distance threshold, you start merging these clusters together based on how close they are to one another. So in this case, we have a distance threshold of 0.05. That's because we just did a bunch of ablation experiments, and we kind of saw that that was the optimal kind of setting for this. Anything below that is too strict, and anything above that is too flexible, right? So we need to find kind of a middle ground that works for everything. So as you can see, this resulted in this orange cluster, which has 3 elements in it. And they all basically say that the answer is Earth, regardless of how they word it. The green one says the answer is Saturn for blue. And then the last one on its own is Mars in the blue cluster. So once you have these clusters, the next step is to actually apply the Syndex formula to quantify whether there is a hallucination or not. So what Syndex does, it basically evaluates clustering quality by measuring things like coherence and also distributional balance through an adjusted entropy formulation. So as you can see, the general kind of equation is very similar to the entropy equation, but the difference is that here we use p theta. So p is basically an adjusted proportion of cluster I. That's defined as this. So you start with pi, and pi, again, if you go back here, you can see that pi for the orange cluster would be, you have 6 total generations, 3 out of the 6 are in orange. So the pi associated with orange would be 3 out of 6. And then 2 out of 6 for green, and then finally 1 out of 6 for the blue cluster on its own. And then once you have this pi for each cluster, you then multiply it with this cosine similarity. And this term basically denotes the average pairwise cosine similarity of the points within the cluster. So what this basically does is it determines whether it rewards basically how tight and semantically consistent the clusters are. But it also penalizes if there's large amounts of fragmentation and ambiguity in the generations. So if you give it a query and you end up with 6 different clusters in the end, that clearly shows that there's a lot of fragmentation, means there's high inconsistency. So most likely Syndex will be very high. And so there's more likely that there's a hallucination here. So I'm obviously not going to go through all of this in detail, but what you need to get out of it here basically is what we tried it on 4 different LLMs. So we tried it on 2 different versions of Llama, and then Falcon and Mistral. And we applied it on 4 different QA data sets. And in this case, we used different types of QA data sets because we wanted to make sure that it works in different contexts. So things like medical data and also just normal trivia data and so on. And when we compared our Syndex approach with other approaches, 5 different state-of-the-art baselines, as you can see, ours outperforms all of them in all settings, basically, which goes to show that Syndex is very effective at capturing a hallucination with using this pipeline that I just described. So again, the main points of why this works, right? So we care about capturing meaning rather than the words themselves. And this is very important because we want to understand what the LLM is saying, not how it's saying it. And the second part is that these clusters that we create using hierarchical clustering, they create very coherent semantic groups that we're able to use to then apply Syndex to the measure. So why the measure works is that it adjusts for 2 things. It adjusts for distribution across the clusters and also semantic coherence within the clusters themselves, which kind of captures the overall likelihood of there being a hallucination or not. So to kind of, now that we have a sort of pipeline where we can detect hallucinations, right? The next important step, we don't want to just detect them, we want to actually fix them. We want to mitigate, right? So to build on this, there's this whole work on hallucination mitigation. So again, lots of literature, a very huge body of literature on different mitigation strategies. You have things that are more non-automated, things like including a human or an SME to basically validate the output and fix it. And then you have more technical automated approaches that are related to things like fine-tuning, post-processing techniques, and things like that. So what we kind of wanted to contribute to this literature is by introducing SAFE. So SAFE is a sparse autoencoder-based framework that is kind of for robust query enrichment and hallucination mitigation. So query enrichment is basically related to the whole idea of prompt engineering. We try to fix the prompt to make it easier for the LLM to be accurate. So this figure here is basically kind of an overview of how this works. So you have an initial query, you give it to the LLM. In this case, the query is what happens if you drink a bottle labeled "drink me," right? And then the LLM gives you a response. You'll likely find yourself drinking, shrinking, or growing. And this is obviously probably due to data it had about movies or something fantasy related, which is not realistic, right? So once you go through this kind of SAFE pipeline, what it does is it adds a node, appends it to the original query that tells the LLM to consider or not consider specific concepts in its response. So when it goes through the SAFE pipeline, it basically tells it do not consider mentions of the term fantasy. And when we provide it with that, we see that the LLM's response changes and it becomes more realistic, right? Which is kind of the response that we want to get in this case. And this is a real response from the data that we got, like one of the outputs. So before I get into it, I wanted to, again, overview sparse autoencoders, particularly in relation to LLMs. So the sparse autoencoders are basically a neural network that's trained to recreate input data, but they do this with a compressed sparse hidden layer. So they force the model to learn distinct meaningful patterns, so some like features in the data. So when we think about this in the context of LLMs, if you have an input that's a hidden activation from an LLM, like from a transformer layer, which is what I started the presentation with, the output would be a sparse codes that capture these high-level semantic features. So if you give it text, it would output essentially like trigger certain large concepts within that LLM. Things like, oh, this text has a medical tone to it, or there's legal phrasing in this text. This is obviously based on what the LLM was trained on. So why we use sparse autoencoders in LLMs? Because these LLMs, as we know, they're very huge, right? So they store knowledge across millions, if not billions of neurons, and they keep getting larger. So these autoencoders, they help us extract and group these neurons into human interpretable and reusable features. So they basically tell us what's being triggered once it's presented with certain text, which is what we kind of want to use in this SAFE pipeline. So to do this, we basically came across this platform. It's called Neuronpedia. This is an interactive crowdsourced platform that helps catalog and explain what individual neurons in LLMs respond to. And it's sort of like Wikipedia, but for neurons inside LLMs. So how it's built is it basically hosts like different sparse autoencoders related to each LLM to identify and isolate different semantic features when using a certain LLM. So what's nice about it is that it kind of lets users explore and annotate these features through a very nice and user-friendly interface. So I'll show you here, this is an example of this is basically the interface. So there's different LLMs that are hosted on this platform. So in this case, we have Gemma. If you provide it with a phrase like "I love Georgia," you can see the different neurons or different concepts that were triggered when you provided with this text, right? So the first one, or the first two, are related to the state of Georgia in the US. But then you also have different types of Georgia in the data, like Georgia and institutions. For, as we know, there's the University of Georgia Tech. So based on this, we can see that this LLM was probably trained on data where it's seen Georgia in multiple different contexts. So that's basically how you use it, and it's very, very easy. There's a UI for this, and there's also an API that you can use if any of you are into coding and kind of playing around with it. That's also an option, and it's completely free. So because of this, we basically came up with SAFE. So how SAFE works is that it uses feedback from these sparse autoencoders to reduce hallucinations in LLM responses. So the approach has two main steps. So the first step is actually detecting whether there's a hallucination or not. So this is using something like Syndex or any other kind of hallucination detection technique, as long as we get a score out of this technique. So once you have the score, you set a certain threshold. If it falls above a certain threshold, you then move on to the next step, because this kind of triggers the fact that, oh, there's probably a hallucination here. Let's move to the next step and try to fix it. So the next step involves enriching the input query with meaningful relevant features, which can basically help the model kind of guide it towards query relevant features that improve response accuracy and also relevance to whatever it is that you're asking it. So the core idea here is that we don't really need to add any new knowledge to the LLM. We don't have to have access to large data sets where we have to fine tune or anything like that. We're simply using the model, using the data that was already given to the model in the pre-training stage. We're just steering the model to better use what it already knows. And SAFe does this by selecting most relevant features that are learned during the pre-training stage. So to kind of go over this is again the main kind of figure of the pipeline. So you start by giving it a query. Once you get an output, you then move on to the step of the detection. So again, here detection, I kind of say it's index, but really we kind of designed it in a way where it could be plug and play, which means that if there is any hallucination detection method that you're able to integrate in this, that outputs a score, then you can easily use that. So once you have a score, if it does not meet the threshold that you set, then it moves on to the next step, which is the query enrichment part. And this is where the query and also the outputs, the responses, are processed through the sparse autoencoder. And this is basically done to extract informative features that can help enrich the original query. So it's sort of like a cycle, right? So now you have the informative feature, you go back, you enrich the query, and then you provide it to the LLM, it gives you the output, and you kind of go in this cycle until you meet the threshold. So once you do that, basically tells us, okay, now we met the threshold, it's very likely that now the hallucination has been mitigated or fixed. So I wanted here to show you some of the results that we got so you kind of understand what it looks like. So again, the first one is similar to the first figure that I showed you. I want to go to the last one, which is a data set called Wikidoc. So as you can see, the initial question is, what is NCHIP? And in this case, it's interesting because this has two different meanings depending on the context, right? So as you can see, the LLM's first response is related to the fact that it's a platform for developing and deploying ML models on edge devices. But in this case, we're dealing with a medical data set, so it probably means something else in this context. So once you put it through this whole pipeline of SAFe, you see that the note that it gets enriched with is that do not consider references to user input, system responses, or technological advances, and so on. And once you provide it with this new enriched query, you can see that the response changes and actually becomes relevant to what we actually want, which is it's a technology that enables the analysis of biological samples using microfluidic chips. And these are obviously some specific case studies and data sets. If you want to know more, then the paper is available. You can always go into it deeper. So again, the main three reasons why this works: it helps the LLM focus on what it already knows. So it's simple in that you don't need to have much to begin with. You can just use what is already available to you. It encourages relevant activations by reducing any noise or any off-topic responses that could trigger certain hallucinations in LLMs, right? So again, it steers the attention of the LLM to certain concepts as it's generating a response. And the last thing, which I said, and I think it's the kind of the biggest selling point, is this: no fine-tuning involved at all. So it works strain-free like a plugin. As long as you have access to the sparse autoencoder and the LLM, you're able to do this. You don't need anything else. So before I end, basically these are, final thoughts. There's still lots of work on building trustworthy LLMs, and it's still something that has not been solved. And these two works that I did are kind of a step closer towards that, but again, there's still a long road ahead. And especially as these LLMs grow in power and prevalence in everyday tasks that we do, their failures become a lot more consequential. So we need to figure out a way to make them more trustworthy. So our ongoing work includes still building on this detection and mitigation of hallucination work through tools like SAFe and stuff like that, and building on them. And also, in addition to this, to also go towards more trustworthy LLMs, we are exploring a deeper reasoning. Reasoning is a big hot topic in the literature right now, because if we're able to elicit proper, accurate reasoning from LLMs, then it becomes more trustworthy, right? So before I end, I'll show you a quick kind of sneak peek into some of the reasoning stuff that we're doing. So this is one idea that we had to elicit better reasoning from LLMs. It's called theorem of thought reasoning. It's I'm sure you've heard of chain of thought reasoning. So it kind of builds on that. So in the cognitive science literature, there's generally 3 types of reasoning that humans use to make certain decisions, right? So you have abductive, deductive, and inductive. So we were like, okay, since this whole idea of agents is also a very big deal and it's been effective in many different contexts, why not use it in this case as well? So we have 3 different agents or 3 different LLMs. We provide the same query to these 3 LLMs and ask it to respond to this query in one of the types of the reasoning. So one of them does abductive, one of them does deductive, one of them does inductive. And then based on that, we essentially produce these reasoning graphs and get a score. And the one with the highest score is the one that was chosen as the optimal kind of response to this. So these are the preliminary results that we got, as you see in the graph here. So we compared our response to our pipeline to chain of thought, and also 2 other more recent baselines that are related to reasoning in LLMs. And we did this across 3 different LLMs, so Mistral, DeepSeek, and Phi. And when testing it on 2 different types of data set, we see that ours actually outperforms, or at least performs very similarly to the state of the art. So this is kind of an ongoing work. Hopefully we'll build on top of it. This paper is available kind of as a preprint, first version online, so you can also go through it if you are interested. So yeah, just to end, these are the links of that you can kind of take and note down. So the first one is the GitHub page link to, I'm part of the Urban Intelligence Lab. So this lab obviously is not just me, so I do the LLM hallucination stuff, but we're more than 10 people, so there's different work like AI and material science, you have computer vision, you have cyber-related problems, and whatever code is available would be on this GitHub page, so feel free to access it. And the second link is my Scholar page, so all the papers that I spoke about today, they're already on Scholar, so you can access them. And yeah, and this is my email if you ever want to reach out to discuss anything. Thank you.
Great. Thanks so much, Samir. So 2 things. Number 1, if I could just ask folks, if you could just move a little bit, folks, can you just move a little bit to that side so I could just go in? And Samir, remember we said that we're going to test who is paying attention. So we have a couple of minutes before I go into the build announcements. We're going to take questions. But before they ask, I want you to ask them 3 questions, and whoever answers correctly, we'll get them the mark. So go ahead.
Okay. So the first one, I think all 3 of them I answered very clearly, so hopefully it won't be too hard. So the first one is, can you list and define one type of hallucinations, like the clear, and an example if possible? Yes.
Contradictory hallucinations.
Mm-hmm.
So for example, we have the very simple one, an engineer. It's just the fact that that's one. And we have the relation error and sensor.
Do you have an example? Give me an example of one.
Example of the sentence error. So Paris is my favorite food. Paris is not a food. Paris is a city.
That's right.
Excuse me.
That's
Great. What's your name? Ahmed. Muhammad. Not that far. Good job, Muhammad. So what's the next question?
So the next question is, can you explain the difference between regular embeddings and sentence embeddings?
So regular
Guys, raise your hands.
the regular embeddings focus on a single word, while sentence embeddings would focus on a complete sentence. So technically, in sentence embeddings, you will see the whole context, whether the whole context of the word is sentence is correct or not. And while regulars focus on a word, you can't really tell whether it's correct or not, or a hallucination.
That's correct. That's the answer.
Great. Good job. What was your name again?
Muhammad.
Another Muhammad. Muhammads are on fire. Pass this later to you. And last question?
And the last one is, what is the reason or the advantage of using these sparse autoencoders in LLMs? So what do they do? Yes.
The enrichment of the prompt that you are giving.
So what gets us to that?
Sorry.
So why do we use them, right? So these sparse autoencoders, why do we need them to kind of enrich a prompt? How do they get us to enrich?
Information is not enough to read them.
They create an extra layer of.
Focuses on what it already knows.
They do fact check. Basically, it creates an extra layer where it queries again and again.
So you have all the training data that was provided to the LLM in the pre-training, right? So we said that these LLMs are consisting of a bunch of
Neurons.
right? So what do these SAEs do?
They focus on the neurons that match the context of your prompt.
Yeah, that's
Coherence.
pretty much it.
Observe that him.
Yeah.
See you later. Great, awesome. We have a couple of minutes also. If anyone wants to ask Samir any questions, do we have any?
One question.
Yes.
First of all, congrats on your great work. It's a very challenging problem. So my query is about: is there a single LLM that doesn't hallucinate? Because the work that you mentioned, it's you try to contextualize, you try to enrich the information. It's all about or you try to improve the data. The accuracy of any model is already associated with the data that you have, but also it's associated to the method that you have. So I studied theoretical master of computer science, and we have two methods, proof by induction and contradiction. And for this, it's also important to know that the hallucination itself is an outcome of the method or not, because as I see it really looks like the other methodologies you apply to correct is related to the data. And in a world that we are full with the bias, it's there can be a point that we come to the very clean, accurate data, but if the method is already hallucinating method, let's say, there is no meaning of having the accurate data also.
Yeah, I mean, definitely, that's a great point. First of all, right now we have not gotten to a point where we can say there's a perfect LLM. That does not exist, right? So every week you get a new LLM now, and it gets a bit better and better, but we're still not completely there yet. So again, the reason is, one of the main reasons is data, but like I said, another reason could be how we use the LLM, right? So things like how we word a certain question, that might be completely foreign to an LLM. Might know an answer to this question, but we just worded it so randomly that it just doesn't completely understand, right? So it can't map it to whatever it was trained on.
I would suggest to check the contradictions itself. So sometimes when we try to do things, we try to, ask that, are you sure this is the right method? Or this, when you say this is wrong, it can just, reassessment in the, there's a false. So I see, as a kind of computer engineer, I see that the whole methodology is based on the capturing the correlation. And if you cannot differentiate the correlation, because when you have the correlation, it doesn't mean that every single aspect of certain thing is correct. But scientifically, when we see some correlation, we try to benefit from it, right? So I think the whole aspect of the LLMs include the correlation, but not more theoretical aspect. I'm not sure it's going to be solved soon or not.
Yeah,
as a feedback, I can suggest you to merge this induction and contradiction.
That's a great idea. I mean, actually, the main kind of limitation, I would say, in the current LLM research is that there's so much that we don't know about how they work, right? No matter how open source, we're still trying to figure out and make proper notation, theoretically speaking, create notation that we can then use to explain things theoretically. That is still a gap, really. Yeah. So that's definitely a great point. Yes.
Is AI hallucination a fundamental issue? So is it, how can I say this? Is it can we like 100% avoid it in any way, shape, or form, or will there still be just a little bit of hallucination every now and then?
So again, right now, I mean, it's not 100% solved, right? We're still trying to build on the literature and work on improving it. So as you can see, I mean, we improved the accuracy as much as we could, but still there's a discrepancy there. And it's all related to different things. Like I said, again, there's so much data that they can be trained on. There's just some stuff that they've simply never seen before, right? So there's a very high likelihood something that it's never seen in its training whatsoever, it'll probably get wrong. So we're not at the point yet where we can say there's 100% an 100% effective way to mitigate them or to fight them. That's basically what we're trying to solve or help at least improve.
I think just to add on to this one, like, is it like something innate with LLMs? Like it will never be avoided to always just reach, like you just try to mitigate it as much as possible. You'll never reach 100%.
I would say that's probably where we're at right now. Like that's kind of what the literature is going towards. We try to fix it as much as possible, but at the end of the day, there's so much that you can do, right? So you try to validate, you try to quantify, but
so it's a solvable problem or like unsolvable? Like you're not.
Right now, it's a question mark. I would say it's not 100% solvable. That's why there's so much literature coming out every day about it. They're still trying to fix it.
Yes, thank you so much for the session. Quite interesting. Talking from an end user perspective, okay, I believe the whole purpose of AI, or specifically the LLM, is to let me say translate my human normal language and give me a result. Okay, so again, talking from this side, how are we able to determine hallucination? Like, what would be the procedures in that sense? Because the users might not be aware that they provided wrong prompt, and at the same time, how the tool itself, like, is it, for example, if I took ChatGPT on top of my head, is it like reading from the feedback? Like after they provide you with the answer, does it is it affected with the, like, does the answer satisfy you? They give you a little thumbs up and thumbs down. Yeah. Is it somehow connected? And even sometimes not all the users are care to provide feedback. So from this perspective, how to determine the hallucination, or how it's going to be detected?
So a lot of the stuff, like for example, the work that I explained today, we're actually working on trying to figure out a way to integrate them, sort of, if you think about like a plugin, you know, where you can have it and it can kind of give you like an alert, like, oh, this seems to be a hallucination, maybe double check it, right? So this is one way that you can kind of do it in real time. And there is some existing work out there, but still, as it's getting more accurate, more plugins come out that are more that are better, that are more effective. Your second question, I mean, so these LLMs, they have a memory that's sort of localized, meaning that within a certain chat, if you give it feedback, it will take that into consideration. But they're not trained in real time, like ChatGPT. If you give it like feedback on the spot, it's not going to give someone else the correct answer just because you said that was the wrong answer, right? So they train them, but they train them all the time, but it's just not as real time or as quick as on the spot. So that's a limitation, definitely, I would say.
A hypothetical situation, let's say, right? Let's say there is a story or a novel where the city name and the person name is the same. It causes ambiguity, right? So let's say if a LLM model is trained on that particular novel, and given the user prompts a statement, something like, like he loves Paris, and here in the context, Paris is a city name, at the same time it's a person name.
Mm-hmm.
Do you think this approach will be able to handle that kind of ambiguity, or does it cause hallucination?
So in this case, it all comes down to the frequency of what it was trained on, right? If it sees one instance of Paris as a human name versus 1,000 times Paris as the city, it will most likely trigger like the city as the, you know, the concept that was triggered, right? So it all boils down to what it's most familiar with. So that's kind of where we're at. There's a limitation there, but generally speaking, as you can see, like in Georgia's case, for example, two different things were triggered, two different concepts were triggered. And this means that both of these concepts were clearly prevalent in the training. So it just boils down to that.
Questions? Yep, go ahead.
Actually, I want to share my experience about LLM hallucination, right? when we create any application or write to passing same query, because everyone end user is not done any prompt engineering, or they're not very well on prompting. So better we write a proper system prompt or something, or additional prompt with that, so it get exactly correct result. Even you need to select a proper module with the right like 7B or 9B we are using mostly, and right module selection is also part of that. And second is actually my question is like that. She asked to how we can write to 100% on the hallucination. There are lots of community behind of AI who gives the wrong information on internet. They spread out the wrong information of internet because they want to just prove AI is wrong. So how actually we ride on that?
So how do you write? So how do you prompt, you mean, or?
It's some community because some people are thinking AI get their jobs. So they start to spreading wrong information on internet because they want to train the AI as a wrong information to give. They want to prove AI as wrong. So like a Microsoft or other LLM providers, how can they able to ride on this user's work?
So how are they able to kind of fight this, basically, is what you mean?
Yes, yes. Because they are interrupted to make AI perfect.
I mean, the way, like, for example, if you go to ChatGPT, right, you see, I mean, they come up with a different version of this model every couple of months or even less, right? So based on the feedback of the user, for example, reasoning, like I said, is a big thing in literature, in the work, I mean, day-to-day use kind of thing. So they came up with a model specifically for reasoning, right? Like O1, O3, all of that.
Yeah.
So it's just kind of, I would say, specializing LLMs would be a good kind of path to go down, because then you have LLMs that are specific to specific things. So you'll know when to use what, and as a result, this can kind of improve the accuracy and the use of these LLMs in different contexts.
Better way to we can use the latest, always latest update or LLM.
Definitely, but it definitely depends. I mean, some of the latest updates are very specific. You have ones that are only, image-based LLMs. If you're working with text, that's probably not the most ideal LLM to use. So you'd have to look at a brief description of what's the type of data, what the specialty of this LLM is. If it's not specified, then it's most likely multimodal, so you can go ahead and kind of use it for whatever. But there's ones that are specific, and if you have a specific task, then you can look at which specialized LLM to use for that task.
I think we need to one session to how we can make a DevOps to upgrade these LLMs and
I think some of the announcements I'm going to talk about will help you understand that, and then we can dive deeper into that. There's this whole offering, and specifically with Azure AI, we have Azure AI content safety, you have red teaming, you have evaluation frameworks. So when it comes to implementing AI on an enterprise level, these are all things you need to consider. So I'm going to touch about it a little bit, not diving deep into all the topics, but definitely that's a good point. We should definitely have a session on that.
One last question from my side, right? Regarding this approach, like how does it affect the model performance? Currently, let's say we are going with the safe approach, right? It takes time to answer, right? For example, the normal average time, let's say, is 10 seconds to 30 seconds. If you're using the safe approach, do you think the model will respond in the very same time, or does it impact the response time?
So no, I mean, definitely speed or efficiency is a big thing, right? That's
a lot of operations have increased in this context.
And definitely you're using a sparse autoencoder that adds another layer to it. That's the next step. So we're working on basically trying to make this more efficient. Right now, it's definitely slower than a normal generation because, again, you go through the whole pipeline, right?
One of the alternatives, at least one of this, I think I've attended one of the sessions here where we discussed to have line of LLMs, like a chain of LLMs, you can say, where you input and it will check for the prompt whether it has toxic or harmful and all this context. Then it will pass this to the reasoning model. Then the response is again validated by whether it's factually correct or not and all this context. And then the output is given. In this pipeline as well, the response time is hit. But again, the kind of the reduction of hallucination and all this is happening to kind of mitigate hallucination, to kind of mitigate factually inaccurate answers. In this point,
I would say that's definitely a valid kind of way to do this. But one drawback with this would be you're still first of all, you're integrating multiple LLMs together, right? The whole intuition behind this is, let's say I have access to this one LLM, and I want to just keep everything kind of localized within that pipeline. So in doing that, in doing safe, I don't need access to other LLMs. That's one thing. The second thing is that when you have multiple LLMs, there's this issue with, like, if the first one hallucinates and the second one, it's sort of like it builds on top of the other. That has been seen to be an issue, actually, where one hallucinates and one kind of goes off of that hallucination and it keeps going and it just gets worse. So, and again, you need to, first of all, pick which LLMs do you want to use and why these, and you need to kind of experiment. So it's a whole thing to kind of figure out.
In this reference in one of the agentic AI,
Yeah.
they use this chain of.
Yeah, definitely. Yeah.
There was a question here.
Yeah, mine was just about the sparse autoparser. It's going to be hitting the cost as far as the GPU is concerned.
Yeah.
What was it about?
Yeah.
Yes.
Yeah.
I heard my.
Any other questions?
We are good.
Okay. Thank you, Samir. Let me I can go ahead and switch screen.
Yeah.
That's fine. So I'm just going to take the next 20 minutes or so just to run you through the latest announcements from Build. So it's going to be like a download, you guys. So I'm not going to stop for questions because there's like a lot to cover. But then if there's anything you're interested in, we can talk about it during pizza, or we're definitely planning to have sessions around these points. Okay. So let me go ahead and switch screens here. Let's go. Okay, so again, Build is our annual developer conference, and there's been a bunch of announcements there. If you can go ahead and scan this QR code to see the full list of announcements that I'm going to cover. Could you turn off the camera? If you just see the camera button there, just like turn it off. Unless you guys want to stay or checks off. Yeah, so we have a bunch of great announcements around everything like Microsoft ecosystem, Copilot Studio, SQL Server 2025, a bunch of stuff. I'm just going to cover the AI part, and that's already a lot. Okay, so are you guys ready for this? There's like a bunch of things to cover. Okay, so this is an overview of what I'm going to talk about. We're going to talk about the latest Azure AI Foundry innovations, and if you don't know what that is, just going to give you a quick overview. Hopefully, we get a bit of time for demo. I'm just going to show you the platform. We're going to talk all about agent services. We're going to talk about the latest innovation with Azure AI Search and the agentic retrieval, the built-in agentic retrieval method. We're going to talk all about security and governance. That's something I think you'd be interested in. How to make it easier for developers to build systems that are more automated, have observability, the integration with Copilot Studio. And also, lastly, the one that I'm really excited about, Foundry Local, running Foundry locally on the edge or just on your device without connection to the internet.
LLM Studio on your LLM Studio. You know that.
With more things to offer and enterprise readiness that you would see. Okay, so let's talk first about Azure AI Foundry. So who here has used Azure AI Foundry before or is aware of Azure AI Foundry, right? So Azure AI Foundry, what is Azure AI Foundry? It's whenever you want to do something AI, build generative AI applications or any AI services on Azure, you would use the Azure AI Foundry platform, previously known as Azure AI Studio. So when it comes to building generative AI applications, when we're talking about enterprises and developers and actually putting code out there that's integrated with your applications, you want to know what's the right tool, what's the right model to use. It's very hard to develop the system actually. You do something in VS Code, and then sometimes you want to integrate with another tool, constantly switching between different user interfaces. You want to be able to easily orchestrate between different. So let's say you talked about the concept of agents and how an agent has tools. You want to be, you don't want to maintain a lot of spaghetti code just to make this one function work. You want it to be seamless. And sometimes you don't know where to start. You want to have some templates as a starting point to just get you up to speed. You care a lot about evaluation. You can't just put one of the things. Actually, I think there was a statistic that I don't know how many percent, 80% of generative AI POCs, they don't make it to production. I'm just making that up. Don't quote me on it, but it's a really high number. And then a lot of it has to because we still haven't figured out properly how to evaluate it. Yani, how do you know, okay, this is ready to go live? This is something that's still like people are figuring it out. So you want it to be more seamless. You want to have like right now the way a lot of people are evaluating generative AI apps, sort of like like the vibe checking, like, oh, this seems right. Like there's no like numerical way, or there are some frameworks out there, but it's not being widely adopted, or people are not aware of it. There's no standardized method. So I'm going to talk a little bit about how Azure AI Foundry could help. You start with a POC and then suddenly goes to production. You want to make it easy for you to go to production. Don't want to like rewrite everything. You can easily start as a developer and then like with a such a button, change the SKUs so that you can handle like thousands of users. And of course, you want to monitor. You want to see how people are interacting. And what are you mentioned like thumbs up, thumbs down. Let's say if you're building something internally, how do you know like which responses were good, were bad? How can you use that to retrain the model, for example? So this is what developers want. And this is where Azure AI Foundry comes in. And this is the promise that Azure AI Foundry gives for developers. So Azure AI Foundry, when it comes to, let me just take a step back because I mentioned Copilot Studio. And I just want you guys to know where Azure AI Foundry fits in. So when it comes to Microsoft and doing AI, there's sort of like 3 levels, right? So just how you have like SaaS, infrastructure as a service, platform as a service, and software as a service. It's similar at Microsoft. So Microsoft, you can do whatever you want. You want to build your own LLMs on like, you have some, you want to like work on a VM and all of that. Microsoft allows you get individual GPUs and you do it yourself. So that's infrastructure as a service. And you want to do less management. You want to just like click a bunch of things and create your agent. Maybe like as a business user, so I don't know how to code. I just like clicking and dragging things. So that's where Copilot Studio comes in, and Microsoft 365 Copilot. It's meant for like regular people, and we have a lot of customers that are using it to build their own agents. And then Azure AI Foundry is sort of like a PaaS. It's like a platform as a service. So it's for folks who are developers. They know how to code. They use VS Code. They're more on like the hands-on side of things. Azure AI Foundry is for those developers. So just to let you know, like, what's the story when it comes to AI at Microsoft. Okay, so this is Azure AI Foundry. So it's a platform where you get to see over, I don't know how many models do we have? I can lose track of things, like over 10,000 right now. So there's the Azure OpenAI models, right? So you have OpenAI and then you have Azure OpenAI. Azure, we have OpenAI are partners. So the same day a model gets released on OpenAI, it gets released on Azure as well. You might be wondering, like, okay, like why should I use Azure OpenAI? It really depends on what you want. If you're an enterprise specifically, you care a lot about security, governance, your model running on a region that is approved for you, and like your security team. You don't want the traffic to travel over the public internet. You want it to travel through like private connections and all that stuff. So that's the promise that Azure OpenAI makes. And you're not just limited to OpenAI models. We have like over the thousands of models that are available on Hugging Face. We recently introduced Grok as well from Twitter, X, and Llama, Cohere, bunch of other models that you're going to see. So we have thousands of models, and then we also have the agent service, which is I'm going to talk about in a bit. And then you have all of these other AI services like translation, video, speech, image generation. And then you also have Azure ML. Like you say, you're a data scientist, you're building a prediction model. You can use Azure ML, and then content safety is all about ensuring security, detecting if a certain response is not in line with certain security metrics, like it has like harm or aggression detected. It's like built out of the box. Guys, I'm like downloading on you. I know you're just like, oh, speak slowly, but I promise we're gonna double tap into them later in future sessions. I just want to make sure you guys like get the keywords so like you get excited about it. Okay, and then Azure Foundry easily integrates with the tools developers love. VS Code integrates with it seamlessly. Copilot Studio. So let's say you want to start with like some low-code stuff, but you want to do also some advanced stuff. Very easy to integrate them. Let's say you don't want to do it through the platform. You want to do it using like software development kit, like through some Python code, or even .NET. I think .NET, Python, and C#, if I'm not mistaken. I hope I got it right. We have frameworks for that. And then, of course, the the extra layer of like, you can run it with container apps, it integrates with functions. And then you also have these ones, which I'm going to talk about in a little bit about how it integrates with your local machine. Okay. So let me, before I just like dive deeper, I think it's easier for you to see it. So I'm just going to switch my screen here. So I just go to ai.azure.com. So this is a service. So you have to go to Azure, like your Azure portal, which is our Microsoft Cloud. You have to go and search for Azure AI Foundry, and then you provision it in a region of your choice. Okay, after you provision it, these resources are created for you. Then you come to this platform, and then this is what you see. Okay, so here, like it's just the stuff I talked about. So for example, I go to model catalog, and then I see all of the different models that I can easily access. So for example, even DeepSeek. So there's the DeepSeek one that's like out there running in a server in China, which probably is not a good idea to use. But DeepSeek is open source. You can easily just provision it here and run it in your own secure network and integrate it to their applications. Sora, a bunch of Microsoft models as well. These are all the new ones that were introduced to GPT-4o Mini, real-time voice. Deploying it is as easy as just like clicking on it and deploying it. So you can come here. Let's say I want to deploy O4 Mini. You get to see the actual model. I think I have a bunch of tabs open. That's why it's a bit slow. You can come in here and then click on use this model, and then you can deploy it. You can also, let's say, fine tune it. So you can easily like bring your own data to fine tune it. Anyone knows the difference between fine tuning and then just using the model out of the box? I talked about this a bunch of times, guys. If you were attending the session, not come on, Sammy, not you. Yeah, anyone wants to give? Yeah, go ahead, Lisa.
You're already giving it some data, so it knows what to expect. So then it sort of like defines within the tasks that you expect of it based on the data you're given. It would treat your data in a more specialized way, in a sense that it knows what kind of input will come on, but then in general, you're just dealing with a general model.
Mm-hmm. Yeah. So to add on to it, thanks, Yusra. So to add on to that, just think of it like this. I always use this example. I read it somewhere and it just stuck with me. Just think about it when you're going for an open book exam or a closed book exam, right? So these models, these LLM models, that's why you see a date next to them. That means that's their cutoff date. They only have the knowledge for like, let's say, June 2024. So if you ask it, hey, like who won the Premier League? Like it's not gonna know who won the Premier League because it doesn't have the products. Who won the Premier League? Was it like Liverpool? Yeah, so it won't know that. So you need to give it some context. That's why a lot of enterprises, when they want to make it work, they bring in their own data, right? They give it the context so that it can answer. Just like how you have an open book question, right? Open book exam. You see the question, you go open the book, find the right answer, and then like with that context, yeah, you write down what is the answer. With fine tuning, you don't have access to that knowledge. You spend the night before, and then you just like change your brain, like your neural networks, whatever, and then you embed the knowledge in your brain, and you go to that exam, and then you solve it from memory. So think of it like that. So some enterprises or some businesses, they prefer going with fine tuning when they see that the context is getting too large. They want something very domain specific, like medical. Or medical AI, or like some legal use cases. Like they want the knowledge to be embedded in the brain. They don't want every time that you'll open the book, see what's the answer, because it's not there. You want it to be, you want it to have its own flavor. So this is where you could find it. And with Azure AI Foundry, you can easily do that. It's very straightforward. I'm not going to give you a demo of it, but you just need to have your data there in a specific format, JSON-L, and just give it there, and then you will be able to see the model being fine-tuned, and then you can deploy it and integrate it to their application. So let's see here. I just want to give you, just make you see the playground as well. So you have the chat playground where you get to play with all of the like text models. You have the video playground where you get to work with Sora, which is the video generation one. So like, let's say I was just testing something right now. I just asked it, like Azure Culture Community in a meeting room discussing like discussing something. So it just generated that. Like, let's say if you have a specific use case, you want to generate video, and Sora is the only model that can, only video generation model out there that can generate more than 15 seconds. If you have specific use cases for that, you can use this model. And then we also have the images playground for image generation, audio playground. So you want to do something real time. We announced the voice live APIs for real-time voice generation. You can also customize your own voice. Let's say you're enterprise and you have like your own branding. You can hire a voice model and then give voice snippets, and then you can have your own voice generation, translation, language, and so on. There's been a lot of enhancements done there that you can read more about in the link that I shared. Right, and then we also have this section called templates, right? Like, let's say you don't want to start from scratch, you can easily just navigate all of these templates that are available, and then you can just go to, it takes you to the GitHub repo, and it's with a click of a button, you can start provisioning it. You just fill in your parameters, and then you can get started. So you don't have to, like, let's say your boss asks you, hey, I want to see a quick POC about how I can use like DeepSeek for my, and for this specific thing. You can just come here, customize it, and then boom, you're ready. You don't have to spend hours doing things. So then we also have agents here. But before I talk about agents, let me just go back to my slides. Okay. Ooh. Oh, I just turned on my mic. Okay. Let's see. So we announced Azure AI Foundry Agent Service being generally available. So just for you folks who are new maybe to like Microsoft or enterprise announcements, usually when something goes out, first it's in private preview. It means like only certain people can test it. And then it goes into public preview. That means that anyone can test it, but it's not recommended for production workloads. Like you just play around with it. Then it becomes generally available. That means that and you can use it in production. If something goes wrong, like the support team will make sure that everything goes well. Like there's an SLA. There's a service level agreement. When it's public preview, it's not. So during my slides, you will see some things generally available, public preview. So I'm just explaining that for you to know what it is. So Azure AI Foundry Agent Service is a service that makes it very easy to create agents. It's as simple as just defining what the prompt is. It automatically out of the box integrates with several tools like grounding with Bing, connecting to a search index, or any customized function apps or logic apps that you have. And I'm going to show you in a bit like what other stuff you can do with it. So first of all, what is an agent? I think you covered a little bit in your talk, but just remember these main three components. An agent has the ability to take an input like from several different sources, and it can reason on top of it, and it can decide on what are the right tools to call to execute this task. So for example, I can give this agent a task, onboard like Maryam. She's a new intern, onboard her. Okay, so this agent knows that, okay, in order to onboard, there's several things. I need to send an IT request. I need to make sure she has like a parking space in the basement. I need to make sure that, there's an email announcement sent to the whole company about her. So it has these tasks or tools in its disposal. Send an email, raise an IT request, procure something. So it has these tools. And then when you give it the task, it goes ahead and executes them until it achieves that objective, right? So this is like high level what an agent does. We had a session on agents a while ago. You can find the recording on it to dive deeper into it. And for those who are waiting for part 2, I promise you it's coming soon. So again, AI agents can reason, act, and learn. So with the Azure AI Foundry agent ecosystem, you have like all of these connectors out of the box. Like say if you have some data on SharePoint or Cosmos, you can easily interact with it. You also have like memory, multi-agents as well are something that you can easily build in Azure AI Foundry. Let's say you can define agent A, agent B, and with just a simple like click of a couple of buttons, you can make these two agents talk to each other. And if you want to do more customization, you can extract the code snippet and then go to your VS Code and customize how these different agents talk to each other. And also we have all of these new protocols. We have like, agent to agent, MCP. I'm not going to dive deep into this because that's like a whole nother topic. I think we talked about it in one of the sessions, if I'm not mistaken. So we can have another session on top of it, or if anyone wants to deliver a session, you're open to that. But we like Azure AI agents has these protocols embedded in them. So these are just like the summary of the announcements. So these sessions I'm going to share with you later, but the longer sessions are available online, and you can check them on the Build website or even on YouTube, where they walk you exactly on the whole, like they show you some demos and how you can get started with this, and live demos so that you can see it in action. So mainly having an agent catalog, support for MCP, and all these like agent ops, tracing and evaluation, all these other cool things. So, so for example, let me just come to my agents account here. So here you will see I have like 2 agents. This one is like my Premier League agent, right? I just give it like, hey, you answer questions related to the Premier League, only short answers and use emojis. And then I give it the grounding with Bing tool. I can even give it some actions, like maybe execute a certain logic app. And then I connect it to my booking agent that I have here, which essentially goes to the website and then books a match. And then I can make this even like a voice-enabled agent, right? So I can, and then let me go ahead and try this in the playground. So when I ask it like, what are the, let's just wait for it to load, like what are the latest matches? I mean, I know the season's over, right? It is over. And guys, I'm not a football fan. I'm just like putting things here. Okay, so let's see here. Of course, whenever you have a live demo, something goes wrong. Let me just refresh. Okay. So let me see if I have a thing to cover. Okay. Okay, so I'm here in my playground, and then I'm looking at my agent. If it loads, ask me any questions if you have until this loads. I promise you it's not this slow. I just have like a billion tabs open right now. Okay, let's go. So let me ask it like, when is Liverpool playing in May? Let's just pretend like we're back to last month. And then I should go ahead, do a Bing search, and then get me the response. And then because it's connected to my booking agent, which handles everything booking related, I can then go ahead and ask it to book a ticket, and then it will do it for me. So I was like, okay, book 3 tickets for May 25, and then then it will go ahead. It will know that right now I only have 1 agent, but let's say if I have several agents, it will know that it needs to execute that one, and then to go ahead and do the booking for me. Right now I don't have any like action for it, but you can make it to send an email or do other things. And then one thing I also just wanted to show, maybe I'll just show it here. If I click on run info, we have these like observability where you can easily see any step by step as a developer. It's like you want to know where it went wrong, like what were the intermediate responses and so on. So we have this concept of threads and runs where you get to see what was the tool executed, what was passed to the tool, to help with understanding this something going on. I'm not going to debug it right now, but I promise you it was working before this. Right? Okay, so the next topic, I think we're already at 8. Is Fatah here? I think he wants to get the pizzas out. I know I'm standing between you and pizza, so I'm going to just delve deeper into it. So we announced Azure AI Search. Who knows what is Azure AI Search? Gosh, okay. Was it?
I haven't really used it, but I know you can basically store your vector embeddings. So it's kind of like a index store.
Yes.
vector database also.
Yeah, not just vectors, but yeah, vectors is one of them. So whenever you want to develop a retrieval augmented generation generative AI application, the sort of R and RAG, enterprises usually go with Azure AI Search. And then we announced a bunch of like built-in features in Azure AI Search. So for example, the one I'm excited about the most is the multimodal ETL. So you have a bunch of, let me just actually skip to that part, because that's the one I wanted to talk about. So when it comes to documents, right, it's not very simple to just like parse them and then make the LLM be able to talk to them, right? The documents are very complicated. There's like some images, there's a table spanning multiple pages, there's charts, there's infographics. So you want, a very important thing is that context that gets passed to the LLM captures all of these different modes of information that are in your document. So we announced multimodal ETL, and ETL is just extract, transfer, load. So just like an ingestion pipeline to basically just bring your documents, and then it can understand the document that's been passed to be able to answer the questions better. So the way it does that, it like verbalizes a specific image that is available. It extracts the different images and it stores them in a way so that when the context is passed to the LLM, it's able to answer better. We have
Going down.
Oh,
Yeah, going down. Pizza is about there, right? Just 5
okay,
minutes.
cool. I think we'll be done by then. Yeah, so this is just a quick demo of how it is. So basically you just, let's say you take all of your data, you put it in a storage account, okay? And then you choose like, Azure AI Document Intelligence to be able to extract and render the data. You choose your OpenAI service. And then you're just defining like how the authentication happens between the different services. Like you can either do multimodal embedding, or you can do image verbalization, which is take the image and generate like a text summary, or you could just take the image itself and then create an embedding from it, and then just save the embedding. So then here you can also set like a scheduler, right? Because maybe your content gets updated every day or every week, so you don't have to, and you have a very hacky code to do the ingestion. Like this does it for you. And then you can schedule it to run like, every day at midnight whenever your data gets updated. And so that's quite exciting. Another thing that was also announced with Azure AI Search is the being able to have granular access control. What we mean by that is a lot of time when it comes to especially big enterprises, again, I keep saying enterprises because when it comes to an actual business, these are things that a lot of times, like, as a vibe coder, you don't think about, right? But you care a lot about security. Security is like number one. So let's say you have a bunch of data in your SharePoint site and you want to do a simple chat with your data to give it to your employees. But let's say like, Khalid is only able to, should only see the HR documents and Yusra is only supposed to see like the finance documents. How am I when I ingest this into my vector database, how do I respect these permissions, right? The way it's currently done is like very hacky, it's not like, there's no smooth way of doing things. We announced native intra-based access control. So while you're doing your ingestion, it will inherit the RBAC controls, the role-based access controls that are on the documents or on the storage account where the document lives. So now all you got to do is just pass the security group or the user ID of this data that you can extract from the documents itself. These are like sources that are available in in SharePoint or a storage account, and then easily it will. Your index will be able to handle that. So you don't need to worry about that. This is like very, very, very exciting, especially for folks who have tried to implement such a granular access control list index. I'm just gonna, and then we also announced this is something in private preview. So whenever you have a document, you have like labeling, this is business, non-business, and public. How do you handle that when you are creating your embeddings? So we announced like an integration with Purview, which is our governance platform that respects that. Okay, and then let me just, I think I skipped one part, which is the agentic search. So when it comes to doing regular RAG, the way it is, it's like multi steps of doing the search and then passing it to the LLM. With agentic RAG or agentic retrieval, it does query planning and then tries to execute different versions of the search query, get multiple contexts, and then merge the results and then pass that to the LLM. And then you can, I'm not going to go deep into it, but there's been extensive evaluations done on this. You might be like, oh, this is just like, a hype, just put agents into everything and then boom, we're happy about it. But no, we've seen the research team has done a lot of tests and they've seen, 40% better RAG relevant answer relevance and results rate. And if you go to the link there, AI search agent retrievals, you'll get to see the whole research paper about it. So we've seen that agentic retrievals almost always outperforms just traditional search. Okay. I hope you guys are you probably shut off your brain right now, but don't worry, this session is recorded. You can always come back to it. Then we talk about model customization, which is everything related to fine tuning, distillation. We announced the availability of these different models for fine tuning. We also announced PTUs for fine tuning. So anyone know what are PTUs? Okay. Yeah, is there?
Provision throughput unit.
Mm-hmm.
Yeah. So it's kind of like your pricing, the way you can price models. So it's generally you have pay as you go, which regularly what we use. So we pay based on the amount of tokens and requests we send. And you pay for what you consume or what you request. PTUs, on the other hand, you request a certain quota or a limit. So basically based on your estimate that within X number of days or month, I consume this amount of quota or tokens. So I can request basically PTUs like 10 PTUs, 50 PTUs, and you're basically billed for the amount of PTUs you request. Mm-hmm. So compared to pay as you go, you're paying for what you are consuming. There's a quota that you're allocated. It's a very general. It's not. I'm not going into.
No, but you got it. You got most of it. So it's one is about pricing. So to estimate your pricing, especially when so a lot of the big entities that we work with and they deploy a generative AI model, they would rarely use a paygo. They would use something called PTUs, which basically so they can predict the performance of their generative AI application. It will always, there's an SLA to it. It will always respond within 5 seconds. With pay as you go, there's no SLA, right? That's one. And then also the costing part. You will know that you will pay just $5,000 for this amount of period. With pay as you go, you can't really predict suddenly maybe someone is using too much of it, so then you would end up paying more. So you need to see what your use case is. Then you would use you would provision the right throughput units. If you're an enterprise and deploying generative AI applications, PTUs are definitely something you can consider. And you can read more about it in the documentation, or you can talk to us about it. And then, yes, so there's also a bunch of other, the sessions that you can look into. Oh, yeah, actually, another thing we announced is the dev tier for fine tuning. So now, if you fine tune and you host, if you do host it in the dev tier, you don't get charged for it, which is really, it's really good. So you can test with it before you actually decide to deploy it. And then for document intelligence, we announced support for extra sources, cross-page table, tables that span multiple pages, face detection, and then lower billing. So for those folks who are using AI document intelligence, this is something exciting for you. If you don't know what is AI document intelligence, I would recommend you to read about it. There's a lot of things that you can do. It's not for building your generative AI applications, sort of with the multimodal RAG, but other exciting use cases as well. And then also AI tools, like I mentioned, the Voice Live API, having generating a voice for audio segment for a video. These sessions really cover it. Content safety. These are also a bunch of other announcements that we made about detecting different, like automatically, let's say if someone passes their personally identifiable information, you can mask that before it gets sent to the LLM, especially for certain industries where you don't want to pass such data to an LLM. So before it gets passed there, you just have this layer of content safety there, and a bunch of other tools to help with trustworthiness. Again, I'm not going to dive deeper into it. It's just, you can always just read more into it, and I'll share these links for you. And then you also have the Azure AI Foundry of observability. So there's a bunch of things here. So I think it's just easier for me to just show you the video. Yeah.
Pizza is here.
Pizza is here. Okay, we're done. Let's see. Why am I not hearing sound? Okay, let us just.
We surface quality. We are excited.
Okay, guys. Okay, I think I need to know. I know what I need to do. I need to just come here, and I need to stop sharing and then share with voice. Okay, share and include sound and share whole screen. Okay, now it should work.
To announce the public preview of Foundry Observability. The developer journey begins with benchmarks and our leaderboard experience, where you can select the best production model for your scenario. We surface quality, cost and throughput metrics, including trade-offs for each model. Once you select the right model, you can transition to the agent's playground to create a proof of concept. Our quality evaluators will be turned on by default, and safety evaluators can be optionally enabled. These evaluations are then run automatically for each agent run with traces for debugging. Use our Azure AI Red Teaming Agent to scan for vulnerabilities and safety risks prior to or after deploying your agent. As you transition to code, you can continuously run evaluations as part of CI/CD workflows in addition to running them locally. In the evaluation summary, we provide operational, quality, and safety metrics with statistical tests to ensure results are trustworthy. Results are also posted to the Azure AI Foundry portal. Once in production, you can monitor your multi-agent system in a unified dashboard, including quality, performance, safety, and resource usage. Quality and safety evaluation results are generated at a sampled rate that you can specify. Traces are available for debugging so that you can easily troubleshoot and root cause issues. For example, if coherence suddenly drops unexpectedly, you can easily drill into specific...
Yeah, so just the main point there is the AI Foundry observability just makes it ever easier for you to think about governance, safety, and then maintaining that through the dev stage and the production stage. There's a bunch of documentations on Learn about it, and we have a whole dedicated session about AI agent observability, which dives deeper into it. So there's a lot of announcements around that. I'm just gonna skip this one, but just to summarize what was in the video, how do you make sure you're tracking the cost, safety side of things? How do you make sure what your agent that's in production, you can actually trust it. And of course, the monitoring aspect. We have all of these evaluators that are right out of the box, we checking for groundedness, relevance, coherence, which are all metrics we use to evaluate RAG applications, detecting for risk and safety, and also all of these other evaluators for agents as well. And you can have your own custom evaluator as well. So then we have Foundry Local. So I think this is the last one. So I'm just going to leave you with this, and then we can go to pizza. And if you have more questions, you can ask me. So let me come here. So Foundry Local is very exciting. You can read more about it in this blog. But let me. Okay. I think there's no sound for this one. So you just install the Foundry SDK or library in your local machine. just like you mentioned LLM Studio, but this has the whole enterprise element to it. You can run it on Mac OS or Windows. So our research team did a lot of work on knowing how to reduce the size of these models. Specifically, we support DeepSeek, Qwen, and a bunch of other models. I think it's mentioned here, 5.4, to run on CPUs, NPUs, and GPUs. So this is also really cool. Like, so let's say you can define your own function, and then with the MCP support, you can do a bunch of things. So let's say you have a function that removes backgrounds, right? So how many times you're building slides and then you have to go and remove the background, go several tools. Let's say you have already a local function, a script that does that. You can just, go to your CLI and then just ask it to remove the background from this image. Or like in the other one, it was extracting the text from a specific receipt, and it runs all locally in your device. And I'm just going to end with this video just to showcase some customers who tried this in private preview and what they're telling us about it.
Hey there, Saba here. Hey there, Saba here, CEO and co-founder of Ambitious Journey, where we've been on an ambitious journey to give developers artificial across the OS. Now, offline first AI is core to this vision. And in late 2022, we began to explore small language models running at the edge between rolling our own llama C++, and then to OLAMA, frustrations around versioning, performance, and end-user experience until our recent partnership with Microsoft on their new end-to-end AI inference solution that offers ease of use and high performance across our team went from documentation access to a production-ready memory management with noticeable improvements in memory management, time to first token, if you're looking to deploy on-device models, you can't go wrong with Foundry Local.
We have been working on AI projects for our customers for several years now. Some clients want to use the latest AI technologies, but are restricted from using external services when the information they want to process contains sensitive data. Foundry Local is a perfect solution for these scenarios, as it allows us to easily run Gen AI models locally. Here, we can see a solution that combines Foundry Local with a speech-to-text service.
Hello, my name is Maria Rodriguez. My savings account number is 123456,
which also runs locally. One aspect we were really impressed by was the simplicity of the installation and the ease of using the models. With Foundry Local, we can now create hybrid solutions, where part of the solution can be run locally.
Yeah, so this is really great for folks who have like a more hybrid situation, like you want to do a lot of things on-prem and some things on the cloud. You want to experiment with things locally before you go to the cloud. Foundry Local allows you to do that. And I think with that, yep, we are done. The last thing I want to end with is, if you do not know about learn.microsoft.com, I recommend you to go there. A bunch of free resources, you guys, that you can leverage to upskill yourself. Remember, I told you earlier, we're hiring. So a lot of the things that they will ask you during the interview, it's all available here. So there's a lot of custom learning paths that you can go to. They're all free. And then you can also talk to the AI to create your own plan. And, if you have any specific questions about what path or what topics you want to explore, you can always we can chat outside about it. So yeah, thank you again for coming. And thank you, Samir, for the session about hallucinations. I personally learned a lot from it. So stay tuned for our next week's session. We also have something very exciting. It's not going to be AI related. It's going to be more relevant for those folks who are developing things. But I would say it is still AI related, because this component, okay, should I just give it up? We're going to talk about API-M. Anyone knows what's API-M? Okay, if you don't know what's API-M, then you need to attend this session. It's API Manager. Okay, no, خلاص cut. Stay tuned for it.